Hey guys, my name is Shreyas and welcome to Simple Chemistry. In this video we're going to be focusing on what percent composition is. A lot of problems when you're talking about stoichiometry like to ask about percent composition, and it's very simple. Let's go ahead and take a look at what it is. So percent composition typically refers to this percentages by mass of elements in a compound. So if you're given a compound, it'll tell you the percent by mass, okay, of each of those elements. So these mass percents can be determined just by looking at the formula for the compound. So in order to get that, you find the mass of each element in 1 mole of the compound, divided by the molar mass of the compound, and multiply it by 100. If you want to see if you did it right, see if the final percentages you get add up to 100. Now this might look a little confusing, so I have an example problem here so you can go ahead and learn. So a question will typically do something like this. It'll say calculate the percent composition of each element in some compound. So in this case we have 66H12O6. So what we're going to do is, there's 3 elements here. There's carbon, there's hydrogen, and oxygen. So the first step, if you look here, is find the mass of each element in 1 mole of a compound. So let's first focus on carbon. So we know that in 1 mole of C6H12O6, we're going to have 6 moles of carbon, 6 moles of carbon, 12 moles of hydrogen, and 6 moles of oxygen. So let's first focus on carbon. So in order to find the mass of what 6 moles of carbon will have, we know that if you look at the periodic table here, kind of difficult to see, but if you look at a periodic table, you'll be able to see that the average atomic mass of carbon is 12.011. So therefore, 1 mole of carbon is going to have a mass of 12.011 grams. So therefore, 6 moles of carbon is going to have a mass of 72.066 grams. Okay, and we got this just by multiplying by 6. So 6 moles of carbon. Okay. Now, before we find the percent for carbon, let's go ahead and do the same step for each element. So let's focus on hydrogen now. So if you look at the periodic table, I'm not going to go there and search, but 1 mole of hydrogen, the average atomic mass of hydrogen is 1.008. So therefore, 1 mole of hydrogen is going to have a mass of 1.008 grams. So therefore, 12 moles of hydrogen is going to have a mass of 12.096 grams. And finally, for oxygen, 1 mole of oxygen is going to have, if you look at the periodic table, it's going to have a mass of 15.999 grams. So therefore, let me write it down here, 6 moles of oxygen is going to have a mass, let me pull the calculator out, 6 times 15.999. So 95.994 grams. Okay, so from here, let me erase this so I can get some more room. So let's first find the molar mass of the compound. So that in order to do that, we're going to have to add this, this, and this. That's the first step. We're going to have to add all of those. So let's go ahead and do that. 72.066 plus 12.096 plus 94.994. 95.994 is going to equal 180.156. Okay? So the molar mass of this is 180.156. Let me write that at the top. 180.156 grams per mole. That's a way of indicating molar mass. Typically you see grams per mole, that's the unit. Okay, so that's the molar mass of this compound. From here, we're going to take each of these numbers and and divide that by the molar mass. So for example, if you wanted to find the percent composition of carbon, you're going to take 72.066 divided by the molar mass, which is 180.156, and then multiply that by 100. So let's go ahead and do that. .066 divided by 180.156. Oh, that did not come out right. Let me see. 72.066 divided by 180.156. Make sure, okay. And then multiply that by 100. And we're getting 40.00%. In order to get the significant digits, just look at these two numbers. This number has 5 significant digits, this number has 6. So let's go ahead and go with the smaller number. So in order to get this to 5 significant digits, we can say 40.002%. We ignored this when we were looking at the significant digits, by the way. 40.002%. Okay, so the percent composition of carbon is 40.002% in C6H12O6. Now let's look at hydrogen. So again, take 12.096 grams, divide that by the molar mass, 180.156, then multiply that by 100. So that's going to get us 0.096 divided by 180.156, then multiply that by 100. That's going to give us 6.714. 6.7142. Excuse me. Okay, because this number has 5 significant digits and this number has 6. So 6.7142. So that's a percent composition of hydrogen. Okay, now let's finally calculate the percent composition of oxygen. I'm going to have to open a new tab for this. Okay, so for oxygen we can take this mass, 95.994, divided by the molar mass, which was what, 180.156, and then multiply that by 100. So when we do that, we will get 95.994 divided by 180.156, multiply that by 100, we will get this, again, and round this answer to 5 significant digits because this is 5 and this is 6, so that will be 53.284. Uh, 53.284%. So the percent composition of carbon is 40.002%. The percent composition of hydrogen is 6.7142%. And then the percent composition of oxygen is 53.284%. Okay, now a good way of checking to make sure we did this right is just add these percentages together and see if they add up to 100. So let's go ahead and see that. So we have 40.02 plus 6.7142 plus 142. Yeah, okay, plus 53.284. Hopefully this will add up to 100. 3.284. Okay, so it is adding up to 100. Of course, it's a 100.002, but if it's very, very close to 100, then you know that your answer is correct. It might be like 99.998, but as long as it's close to 100, your answers are likely correct, okay? So that's how you calculate percent composition. Now let's look at this another example here. a little bit more difficult. Oh my goodness. This is going to be challenging, but if you can do this, then you can probably do any percent composition problem. So first, let's look at, let's break this down to each element. Okay, so we know, again, if you look at 1 mole of the compound C10H16 N5, this is a very complex molecule, N5O13P3, we know we have 10 moles of carbon, 16 moles of hydrogen, 5 moles of nitrogen, 13 moles of oxygen, and 3 moles of phosphorus. Okay, so from here let's find out what the mass of each of these is. So 10 moles of carbon. If you look at the periodic table, the average atomic mass of carbon is 12.011. So 1 mole of carbon is going to have a mass of 12.011 grams, and then multiply that by 10 in order to find out what the mass of 10 moles of carbon is. And if you do that, you will get 12.011. So that will be 120.11 grams. Okay. For hydrogen, if you look at the periodic table, the average atomic mass of hydrogen is 1.008. So 1 mole of hydrogen is going to have a mass of 1.008 grams. In order to find what the mass of 16 moles of hydrogen are, you can just multiply those two numbers together. 16 times 1.008, you get the 16.128 grams. Okay, nitrogen. So if you look at the periodic table, nitrogen has a average atomic mass of 14.007. So 5 moles of nitrogen is going to have a mass of 14.007 grams times 5. So let's go ahead and do that. So it's 70.035 grams. Oxygen. So oxygen, 1 mole of oxygen. If you look at the periodic table, oxygen has an average atomic mass of 15.999. So 1 mole of oxygen is going to have a mass of 15.999 grams. So 13, you just multiply those numbers together. So 13 moles of oxygen will have a mass of 207.987 grams. Let me see if I can fit that in here. 207.987 grams. Okay. And then for phosphorus, I don't actually know this information. Phosphorus has an average atomic mass of 30.974. Therefore, 1 mole of phosphorus will have a mass of 30.974 grams. So in order to get 3 moles of phosphorus, just multiply that together. 30.974 multiplied by 3. So 3 moles of phosphorus is going to have a mass of 92.922 grams. Okay, so from here, let me open a new tab. We can find the percent composition of each of these elements. Let's start with carbon. So first let's calculate the molar mass. So we're going to have to first add all these numbers together. I forgot about that. So 120.11 plus 16.128 plus 70.035 plus 207.987 plus 92.922. Let me make sure this is the right one too. Okay, so the molar mass is 507.182 grams per mole. 507.182 grams per mole. Make sure you're using this unit here, grams per mole. Whenever you're talking about the molar mass of a compound or a element, you say grams per mole. That's the correct way of indicating molar mass, okay? I haven't mentioned that, but this is important. Okay, so anyways, so from here, let's go ahead and find the percent composition of each element. So let's start off with carbon. So for carbon, it's going to be this divided by this, and multiply that by 100, so 120.11 divided by 507.182 times 100. Okay, and then that is going to be 507.182, multiply that by 100, lost the number of reading. Okay, and then multiply that by 100, and then our answer needs to be rounded down to 5 significant digits, so we can write this as 23.682%. Okay, so that's a percent composition of carbon. Now let's move on to the next element, hydrogen. So I'm going to take this number, 16.128, 16.128, and divide it by the molar mass, 507.182, and multiply that by 100, so times 100. Then let's go and calculate that. 16.128 divided by 507.182, multiply that by 100, and we'll get 3.1799. That's 5 significant digits there. So 3.1799%. Next one. So 5 moles of nitrogen for nitrogen. So take this and divide it by that, same thing. 70.035 divided by 507.182. Multiply that by 100, and you will get 70.035 divided by 507.182. Multiply that by 100, and we'll get 13.809%. Okay, just keep going. This is tedious, but you gotta just be neat and make sure you're getting all the numbers right. So here, 207.987 divided by 507.182. 987 divided by 507.182, and multiply that by 100. Let's get the calculator out again. 207.987 divided by 207.987 divided by 507.182. Multiply that by 100, and we'll get this 41.008%. And finally, our last element here is phosphorus. So take 92.99922 and divide that by 507.182. So 92.922, okay. So 92.922 and divide that by 507.182. Multiply that by 100. Okay, so 92.922 divided by 507.182. Multiply that by 100, and that's this percentage. So 18.321%. Wow, okay, so a lot of work, but we got our answers. So the percent composition of carbon within this huge compound here is 23.682%. Hydrogen is 3.1799%. Nitrogen is 13.809%. Oxygen is 41.008%. And phosphorus is 18.321%. So let's go ahead and check our answers. Let's add this up. 23.682 plus 3.1799 plus 13.809 plus 41.008 plus 18.321. Oh god, I hope this is 100. Okay, so 99.9999. So close to, exactly, very close to 100. Sorry, we know our answers are correct. Okay, so As you can see, this is very tedious. Hopefully you'll only get one problem like this on your test. Just make sure you're careful, and you'll be fine. It's very easy. It's tedious, but be neat, and you'll get the answer very easily. It's very simple. Percent composition is as simple as that.